Yeah. So we were discussing about the Docker and then the kind of related keywords, Docker related keywords, like kind of building the Docker stuff and then the running the Docker related things. So you should have a clarity on these things when I say the Docker. Can you guys tell me like what are the things you know around the Docker related keywords?
We have learned about creating Docker file
Yeah,
and building image.
very important. This is the skill set you should have it. Insert the Docker file like from en
From copy
like copy these other things. We will go
and
along with the like when we do the setup right our own applications and all that time we will go more deep in this Docker file. But you should have knowledge it. When I say Docker, the Docker file will be there. So this is very important file to do something, anything that yeah. Next,
then building image.
Docker images. Yeah. Building images. Sometimes we will build our own images. Sometimes we will get from existing images from Docker Hub, and then we will run that existing images also. Yeah.
We have learned how to run the image,
Yeah.
how
Containers.
to push, how to push and how to
Yeah.
run the image.
Pushing images to registry.
Register.
For AWS, ECR we use outside Docker Hub. In AWS, if you want to push where you are pushing it, from that place you should have permissions to push that images. So we don't allow. It's not a good practice to push from your laptop to container registry. It's not a good practice. Best place is to one of the automation server. In the automation server, we will bring the Docker file, code, everything, build that image there, and then that automation server is nothing but one more EC2. Not from your local. We don't run anything in your local. Just write the code. That's it. We don't run anything in the local. We don't build anything local. Send those files to some automation server. That automation server will does all this process for us. It does everything. Yeah. Containers. So what
Yeah,
technology we are using here to run the container here? We did till now we used
Docker.
Docker,
Docker.
but that is not encouraged, right? Docker is not encouraged because
Right.
the replicas, port number management, and then Docker with the Docker, right? Like if you want to do multiple missions, I want to connect from one container to another container, from one mission to another mission. So you should know more Docker inside more technology inside the Docker, like the networking type, bridge, host,
Yeah.
overlay, none. You need to connect with the Docker technology multiple EC2 missions. That's you are making more complexity. There is a technology came which they did automatically that all the connecting the networking say everyone. That's to recommend. This is for test purpose. Only what purpose?
Test.
Are in the local, in your local only. But in the environment, not we don't use at all. It's not recommended at all. If people are using some projects, I have seen it. It's up to them. But best one to the there are the orchestration tools are there.
Kubernetes.
Yeah, container orchestration tools. This is given by the Google company. It is invented by the Google company. Google is the one who invented the Kubernetes, and then they had given as a open.
Open source.
And then these guys, no, every cloud provider, they took
EKS.
investment. They're selling as a EKS.
AKS.
Yeah,
AKS.
Google Cloud, GKE, and then these Red Hat guys. These guys are selling as a OpenShift. These things something. Okay. These people also have Docker also have these guys also have container orchestration tool. One is the
Container T. Swan.
Docker Swarm. This guy's company. This is the Docker company only invited. But yes, there are still some manual steps are there. So best one to prefer anyone this. They'll go anyone this, anyone this, anyone this. They'll go. Okay. So you should have a clarity on this. Docker file, Docker images, pushing an image. We did one time, but that's next time onwards. That is our regular job. We are not stopping at one time. Just we create some kind of flow. That is next. Regularly writing a Docker file, building images, running that something. That is what our job next. Next further sessions. Okay. And then this is the runtime. This is the build time. So two tools, two things you know. Building image, running image. So building image technology, Docker. Running image technology, we are going with the Kubernetes. So this is developers, sometimes they'll use in a local only to test. Sometimes in local also they'll use a Kubernetes technology called. In local also it will come. Local in your laptop, if you want to run Kubernetes, you cannot run EKS in your laptop. To run laptop in local, sometimes they use a tool called Kind also. Kind is mini Kubernetes in the laptop. Just get the keywords, we will see. Okay. So my objective here is why to go for Docker? Anyone like you have EC2 missions, right? Why to go for Docker? When did you get it? What did you understand?
Because we can run multiple containers on a single OS.
Very good.
To memory optimization.
But in the OS, sorry, single OS, yeah. But in the EC2 also we can run, right? Multiple Apaches also I can run. Multiple softwares also I can run. Tomcats, Apache also I can run.
We can run multiple clouds.
No, I mean to say in single OS I can run multiple in the OS model, right? In EC2 also I can launch EC2. I can install Tomcat. I can install Apache also. I can do that in single OS also.
In Docker having
in
binary
OS,
OS, it is.
yes,
Sorry?
cost saving, for a cost saving purpose.
Okay, here also you are
Before-
saving, right? Let's say for example, here also you are saving, no? This is the EC2, okay? This is the EC2. This is also Docker. Okay. Here also, I took one EC2. In the EC2 itself, I installed Grafana, Kibana. Manually I installed, okay? I downloaded the binary, I installed it. Then why still I need to go? Here also cost saving. Single EC2 only, I installed every software here. Everything I installed is single OS. Here you are running containers. Here I am running a separate process here. Then why still? You getting what I mean here? Here I launched EC2. Here I launched EC2. In this EC2, I'm installing all these softwares. No containers, softwares, individual softwares. Then why I need to go for Docker then?
We can give good resource utilization will be good in Docker because we can allocate memory as
Yeah,
per
I need to say we can control each container resources. Yeah. Yes. Here what happens here is, let's say if Tomcat behaves little odd or Apache behaves little odd in this EC2, any one software because a little hot, total this guy will get corrupted. If any one process right here, you took here EC2, here what you took, here also you took EC2, but you installed what software here extra here on EC2?
Docker.
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 You installed it. On top of Docker, you are running the containers. Here in the second model, let me take it. Here you took EC2, here OS, here what are running? Processes. Nothing but what are the processes? For example, Tomcat, Apache, Grafana, Kibana, all this running. But here, what is the model? EC2 will be there. OS will be there. Extra what software will come here?
Docker.
Docker. Here running what? Here you are running all this. Same you are running as container.
Right.
That's if any one process behaves here odd, this guy will get corrupted. This guy will goes away. But if any one guy becomes little odd here, one guy like got corrupted, something stopped and all something, then again what this guy will take care of that. He will not get corrupted. Just only this guy only impacted. Let's say Tomcat is having issue, he will get exited. But others guys will be running their own world separately, isolated world. That's individually. Because those are individual mini operating systems, right? No problems at all. Yeah. This is the one. Yeah. Some more points. What did you observe when we are doing it?
With Docker, any cloud platform and anything we can run it.
Yeah. You can run these containers on any. Only what software do you need if you want to run images? Only software you need one guy.
Docker.
Docker, another name for Docker is called nowadays, they're calling it Containerd.
Container.
Yeah. Just to run, okay? Running only. Building, obviously Docker. Running, either Docker or Containerd. Yeah. Here, this is like vendor lock. Vendor lock in the sense, that's it. You have EC2, only the AWS. Let's say VMs in Azure, only VMs. Google Cloud also VMs, compute we call. They are also VMs. You have a vendor lock here. That software. Yeah, some more. What did you?
We can install the applications very quickly in seconds, within seconds.
Yeah, everything is coming from where here. In the Docker, every installation, the instructions, the steps, everything is coming from where here?
Docker file.
Docker file, exactly. Docker file has all instructions. And that is being included into the image. Here, all those steps, whatever the steps, right, you need to use some kind of scripts. And all those are coming as on top of operating systems. Yeah. Still.
Here we can run only applications. No third-party OS level utilities. We can't run here. Only applications we can run here.
Where? In the Docker or EC2?
Docker.
Yeah. That is what do you mean? Kind of containers.
Yes, containers.
Yeah, you are running it. That's true. What did you observe practically?
It's very fast.
Very fast. Here, let's say I want to bring it up this total EC2. Yes, obviously you have to have a EC2 before. That is true. You should have it. Here, what happens here is, so if I want to bring it up, the boot time, slow. It's up to the how many processes you are installing it. It's slow. EC2 is slow. Container is very.
Yeah, Docker is slim and fast.
Yeah, exactly. So usually they expect you this image. Docker versus VM. We already written it. Let's see. They expect you have this usually in the interviews, right? They expect you this skill set. This is this is the OS. They're using hypervisor like AWS is using Xen, right? This is individual EC2 here, EC2. This is the hardware altogether hardware. Okay. Here is a EC2. You have binaries. Amazon Linux, they added their own binaries central here. But in this case, right, you no need to have any hypervisors and all. Just on the hardware OS, you need bus OS On top of OS, you are installing Docker engine. This is like, here also you have binaries. These binaries, these are lightweight binaries. This is heavyweight binaries. Just you are running a container here. So, any thoughts you want to ask on this image? This is the one of the interview they'll expect you. What is Docker? Docker is, I say, it's a lightweight image which is packaged required binaries only to run application. No extra binaries. User right plus. Sorry.
One more advantage of Docker is while migrating from one software to
That is beauty. Yes, exactly. Yes.
So this is the
Migration.
same question, right? What is the difference between virtualization and containerization?
Yeah. Migration is very up, very fast, I can say. Yes. Here complexity. Yeah, they ask you, this is the question is virtualization. This is the question they'll ask you. Difference
Between virtualization and containerization.
versus containerization. That is what I was telling. You'll have a EC2, OS. Here again the hardware. In the hardware, you'll have a hypervisor. Hypervisor is the nothing but in a single hardware, you wanted to install multiple operating systems. This we discussed in the initial days, how Azure works. Okay. So you will have a laptop. In the laptop nowadays, right? People are going this model hardware OS. Now, if I want one more OS, you need to purchase the one more hardware, one more laptop. Instead of that, what you can do? You can install hypervisor like Hyper-V. There is the tools are the VMware workstation something. On top of that, you can install multiple operating systems in the same hardware. Let's say like this, you can install. But drawback with this is you can install here application app one, same laptop only or same hardware you can install. But what is the drawback? These are the heavyweight. You are bringing this guy. Now what they're doing is just simple. In the hardware, they'll install OS. On top of this, they're installing the Docker engine. Here app one. This is the Docker image. This is how they are going. App two. It's up to the capacity of the hardware. You can have multiple. Here we eliminated this guy. Mostly, which is the guy you eliminated is the OS. You are not packaging applications here. Yes. So yes, this is very important. Migration is very quick. I wanted to run in my local, I want to run in other cloud something. This is very quick. Yes, that is the one. Yes. Cool. So you have the clarity now, the basics of the Docker image, Docker run, troubleshooting steps. When I say troubleshooting, check logs, check containers running or not. Which image? When I say image, in the sense name, :tag, to find out, hey, which image is running, they'll come to you. This is regularly our job. They'll be asking you which image, which tag, you have to provide it. By seeing that URL format, you should have that knowledge. Checking the logs. When I say logs, two things, file or std out. In the container world, which one they prefer? In the
Studio.
Like standout, which is
standard out. Why? The application can write into a file also, right? Inside the container. Why they prefer standard out?
it's actually it's live. They can check directly instead of saving
It's
file.
visible in the console only.
Yeah, console only, exactly. But if you write into a file, if that file goes down, that your container gone. But here, what happens here is standard out will store somewhere in the OS also. There is a path. Sometime you can see the history of the container logs also. There is a previously, it will store some caching into, okay. That, while practically when we do in the Kubernetes logs, we will see that, okay. So troubleshooting steps, this is the basic, you should have it. Container running or not, and which port numbers. Which port number. When you do Docker PS, right, it will show there 0 ... arrow mark, right, something. At least you should have knowledge. OS port mapping to container port. These are the basics, you should have it. So For next topics, right? You should have this knowledge in the mind. When I say image always will be coming from a Docker file. If it is our own image, we will write our own Docker file. If there is outside image, sure there will be Docker file for that. In the Docker file, they'll be using one more base image, or they may be building from scratch image. That is what you should have the skill set. Docker file. Docker build we use, push images to ECR. That is where the Docker will stop. Next, who will come to run that image? Docker, we don't use, test purpose only. Which is the famous guy we will use is the Kubernetes. So we will be going next. This is the complete flow we will follow regularly. I was telling, if you remember, we have architecture, lab, implement. This is what my next job, implement. Full complete flow of Docker build, Docker deploy. That I have one image, I built it. I'll show you at the end of the session. I lost that tab. That is what my next objective. Okay. So you know the basics now, building image. Let's consider on the running environment. Okay. There are the many technologies are there to run the container. Can you guys name some of them? What you know?
Docker, Kubernetes, EKS,
AKS, AKS, Docker Compose, Docker Swarm.
Okay.
Yes, AKS, OpenShift, EKE.
Yeah, OpenShift. Many are there, like many came in the market. So many came here. So these are all like, this was there whenever these guys were not popular. This was popular. We were using it, but things are become very easy now. These two mainly we use for one more. I'll add it here. This is the kind. This is for local testing. This is local in the laptop. In the local laptop, I wanted to test. Then we use in the environment. This I will set it up. Okay, these two we will set it up in the local. Once we come to the one flow, right, we will set it up in the local. These two we will set it up. Test local. If it works, then I'll push the code into somewhere. From there we will build the image. Okay, these are for local testing only. Now, so these are the technologies are there to running the containers now. This is the most famous. Firstly, open source, done by Google company. They give to open source, free. Even the code, everything is free outside. So these guys, they took the software, they implemented easy method for you. What is that meaning, easy implementation? Let me tell you.
yes, we can.
Total in your application flow, from load balancer to applications, which is the most important component in your application architecture?
Database.
Database.
Because that is the customer data, right? That's where we are doing the business. That's where the storage. If you lost that, all company can't. So which service do you prefer here? Why, which service do you prefer in the cloud? Do you go with this model, or write one thing? Where did we run this guy?
RDS, like Amazon.
Where did we run the database guy? In AWS one service, we know. Guys, you are already familiarized. Shouldn't wait for this. Where did we use this guy? Which service did we go for that?
Amazon RDS.
Yeah. We went for RDS.
RDS.
What is the, you can go with this model also, right? Why you went for RDS?
It's managed service by AWS.
Managed, what is mean by managed?
If something goes wrong, they'll take care.
For example,
If we lost or if anything corrupted or something, so they'll get back. And if anything is we missed, we can ask the team to help.
okay. Some more.
And even availability also.
What do you mean by availability, for example?
One availability
Our-
goes down.
So we can keep it in our like different zones.
How are you keeping that multiple zones?
As a backup copy.
Okay. So yeah, you are telling it, but the expectations what we expect you, yes, that's correct. What you're saying is managed, yes, correct. What do you mean managed in the sense? So it's a kind of, I can say, PaaS, platform as a service. And when I go for EC2 mission, right? EC2 is involving the OS related components, everything. When I launch EC2, EC2 is locked to a zone. It's a zone. If I want one more EC2, I need to launch one more EC2, and then it will be in the zone 2. So here, high availability, I have to take care, high availability things and all. And then I need to use my own technology. I need to have a very good database technology, how to make these two as a cluster. If one goes down, forwarding request to another one, I need to keep one more before this, right? Load balancer, I have to keep it. And then here zone 1 database will be there. Zone 2 EC2 will be there. The write will go to one guy. You know, right, in the database technology, you cannot write at a time to multiple hosts. One host only. Remainings are read only. Okay. Now I need to implement all this complexity. If you go to the RDS, they took care of that high availability. How high availability will come? Whenever I'm launching a
RDS will select the multi zones.
yeah, there is an option called multi-agent. But RDS will get created in one zone only.
Yes.
Behind they will take care. Behind they will take care that multiple, you will never have a downtime. But RDS will go to one zone only. But if that zone goes down, here, like you have load balancer endpoint, right? Here you will have an endpoint of the RDS endpoint. Even if the zone goes down, the auto failover to another thing, clustering, all those they will take care. That is the one, high availability. Next, upgradations. Here you have to log into EC2. You need to manually run those. You have to Google the instructions. You have to upgrade manually the steps and done. But here in the RDS console, there is a single instruction will be there. Right click. There will be patch will be there. Just upgrade. They'll take care. Behind without failover or without downtime. So these are the complex like upgradation, maintenance, patch apply something. And then this is very important, backups. Automatically they'll take the backup. You schedule the time. Yeah. These are the complexities here. But technicality possible. Please, I have seen recently one architect guy, they were like, with my experience, I know them, but the skill set, what they upgraded it. They were running in the on-premises this application continuously from like almost, I remember 10 years they were running in the VMs in the on-premises. When they moved to the cloud, they have chosen this method. They went into the till live also. They, because of the skill set gap, right? They missed this one. Now it's okay to go to the cloud. In the cloud, who is managing your hardware?
Ourselves.
Hardware. Who is
Amazon.
managing your hardware? The cloud provider, right?
Right.
Someday, one day, they'll tell you because of my something hardware issue, you cannot recover this EC2. So I have seen that. They'll come to you. There is something we went wrong. We are not able to recover. Please, you have to do something. They'll tell you. I have seen some cases. They'll give hands up. That's it. You are the one will get safe one. If they go to RDS, 100% they'll recover you, but they cannot recover this gun. We've seen it. This they'll take it because they're using the technology behind it. So very careful. That's where I'm coming here. You can take Kubernetes. You can take Kubernetes. You can install an EC2. It's like I'm comparing, okay? It's like database on EC2.
Yes.
But you can take this guy also, AWS service. This is like RDS. Which one do you prefer?
EKS.
Why? Upgradations, maintenance are very easy here. If you want to upgrade from one version to one version, it's like just a single clicks. This is like, this is like, I can tell you, maybe 1 hour or 10 minutes or something. It's up to the complexity. This is like, it will go for a week, months also. So as a DevOps guy, agile, very speed. I want to make it, I don't want to go for complexity. People will prefer this one. But yes, you can take individual EC2 missions. I can take one EC2 group. Let me say you group of EC2. What is the OS I'm going to take? Amazon Linux. Why we have chosen Kubernetes?
Running containers.
To run the container, what is the software you need?
Docker.
Obviously, yes. I'll take a group of EC2, Amazon Linux. What you need to do? Install.
Install Docker.
You need to install the Docker of EC2. Let's say EC2 1. Install Docker. Install Docker. You have to do like group of EC2. Group of. In the containers, what happens here is, even if this goes down, the containers will come in another mission. Okay. What is the model I'm going here? KTS. Individual I'm taking. Then you remember we installed a Kibana, Grafana like this, right? Here also you have to install some Kubernetes softwares. You have to install individual Kubernetes softwares. You have to install. Install KTS softwares. That we will see in the architecture. Individually you have to install. In this group of EC2 mission, right? Let me keep it more complexity so that we'll have clarity. What is this technology I'm telling? Docker or Kubernetes? This one's
Kubernetes.
Kubernetes. You have to install individually. Individually, you have to install KTS software. Among this EC2 mission, very important, one guy or some guys I will call as a master. We need to consider as a one guy as a master. All these guys, I will say as a workers. You need to make that master. You have to consider manually. You have to do all these steps. One guy master, one guy worker under. If I want to deploy an image, Kubernetes will build image or run image. Yes.
Run image.
Run
Run
image.
Run image.
Image, right? It doesn't have skill set of building. No, it doesn't have it. We don't do. Now, very important, very important. Image will run on these guys only. Image run in the sense what I can say? Container.
Container.
Will run on which components? I was telling two components here. Master and
Master and worker.
it will run on where? Directly. Worker only. Can I run on the master? You can run, but not at all good practice. This is the dedicated for other purpose. Can I run my own application? You can run. Possibility is there, but we don't run there. We will run in this one only. In this one. But very important, if you have an image, you need to give to this guy. You have to, image in the sense you have to tell that name, tag, from where you need to pull. What is that place is called? Where is that image is called?
Hub,
Register.
ECR.
That information you need to tell to this guy, master. Then master will decide on which work. What is the drawback in this? There is a one failure or drawback is there, fail thing. There is a chances of failure. Even if this guy goes down, na, my container can run on this guy. But there is a one failure option is there here. If one guy goes down, you cannot deploy at all. But application will run in this. If one guy goes down.
Master.
Exactly, because who installed all this setup? Who did all this setup?
Manually or such.
You are the guy. You are the guy that did setup. Now, for this, I need to maintain what? Again, if this goes down, I don't want to make this go down. What I have to do?
Let have the backup.
Not backup. You need to create one more
Master.
master. Let's say that 1.2 master 2. And then these two, you need to make kind of a load balancer. Again, high availability, management. See, the things are making complex. Let's say if you go with M5 2X large or bigger mission, right? C series something. Individual, I told na, M5 2X large is like $280 something month. So can you guys tell me now with this?
Maintenance, cost.
We have to take care masters. And one more, what are the missions? Workers
Worker.
also. We have to
We have to take.
care. Upgradation.
We have to take.
Upgradation. And one more, you remember? If it is one in the Docker, last time I was telling, na, in Docker host, what is the default network?
Bridge network.
Bridge.
Network. Bridge was there. Here, one EC2 or multiple EC2s?
Multiple.
Multiple EC2s. EC2s will be in VPC network. That they will connect automatically. That they will take a route tables and all. But when you install a Docker, right? Docker will create one more network na, internally.
Right.
This. You need to use overlay connecting from one network to another network. When you're running a container, right? You need to make all this linking container network map, this network setup. All this you have to take care. Upgradation. Connecting of Docker networks. For example, whenever multiple missions comes, na, they'll use this guy, overlay to all upgradations. Let's say if this container goes down, automatically bringing up the, no, that master will take care, that you don't need to worry. For example, like, so upgradation, these master upgradations, there is a complexity, I was telling it. More manual effort. If you go with what option?
EC2. Kubernetes.
Now, this you have to take care. Masters you have to take care manually. There are if you go to the on-premises, right? People are not using EKS. They are still with this method. In the on-premises, they're with this method. You don't have an option because they're not been into the cloud something, right? Still in the on-premises, don't think Kubernetes, Docker only for cloud. No. You can run in your laptop, you can run on on-premises, you can run in anywhere. So yeah, just have that, okay? Now, since cloud came in AWS cloud to run containers, sorry, I could have added here as well, one more option. ECS. In AWS cloud, we have to run the container, two technologies are there. ECS, this is by the AWS. This is the AWS software. Second, EKS. This is Kubernetes software. Okay. Majority companies, they prefer it. Like I would say 90% they'll prefer this one. Before EKS, this was there. Even we were using it, we migrated again to EKS because this is very easy. For DevOps, right? What is the thing? I don't want to waste your time. Just write simple YAML and then deploy it. This is very flexible for DevOps, agile methodology. If you go to this methodology, right? Let me put it here. Same. There is a AMI. There is also AMI. You know what to do. They AWS only given this guys. AMI. Ready-made AMIs are there. Let me put it here. This you don't need AMI also. For this only you have to take it. Ready-made AMIs are there. EC2, 3. Right. This, there is a master will be there. You cannot see that OS. You cannot see those EC2. You cannot see. It is, can you see RDS OS? And what OS RDS is running? Can you see?
No, we can't.
Same way, for RDS, it will be running, right? Like if you go to there,
Yes.
you will have a C status, right? Same way, completely master will be taken care by the AWS. Owned by, who will own it? AWS. The charge, I think per month, they'll charge $70 something for master. Okay. For master, they'll charge. It is fixed amount. $70 is the fixed amount, I remember. Okay. How many EC2s behind running master? You have to take care here manually. Many. They usually, right, in the Kubernetes technology, to master, right, they'll go with this formula because they have some what is that, deadlock, something called brain splitting. They'll go with 1, 3, 5 something. Why? Whenever like 3 are there, right? If one goes down, this two will get compete. I want to become as a master something. The third guy will automatically win. These two will be continuously fighting something. There is a brain split issues are there with that logic. So they prefer 1, 3, 5 something. You have to take care if you go with individual. Here, there is no EC2 missions at all. Completely owned by whom? AWS. So what do you get? Just you will get endpoint. Master endpoint you are. There is no OS at all behind. Master will be there. Master. That they'll take care. What is your job? Take care of to whom? Worker nodes. Next, in future upgradation came. In the UI or from the Terraform, there will be one, just you need to put upgrade, that's it. They'll take care. And the network connectivity. Network in the sense, why do you need? To link containers technology, containers network. AWS will take care. Upgradations. They don't upgrade. Easy here. Just you have to do that. They don't take care any upgradations. You have to tell that upgradations under here. Now you should know the clarity. Kubernetes we can install on top of EC2 also, but that is difficult. That's where people will prefer which one? EKS. The maintenance is very easy. When I say Kubernetes, till now you have any thoughts? You want to ask any questions? Why we are using Kubernetes? Why we need to go for EKS? Any thoughts you want to ask?
So the charges you have mentioned, that is for EKS or only for master?
Which charges you mean, for example?
The $70 you have mentioned.
That is only for master. That is only for master. This worker you have to pay as usual. Based upon the instance type. That is extra.
Understand.
Yeah. This is for master. Because behind how many EC2 missions they'll take care, we don't care, right? Just static.
Right.
This is regular our normal EC2 charge because you are using this for business, right? Yeah.
Understand.
Cool. Now, when I say Kubernetes, any EKS, everywhere this is common. Okay. Two components are very important. Before that, why we are using Kubernetes?
To run containers.
What is Kubernetes called? Container orchestration tool. What is container orchestration tool? Like managing multiple nodes, multiple containers. That is what this is called. Management technology. What it manage? Containers. We don't call containers here. We call container is there, but instead of that, right, we will call direct keyword in the Kubernetes is called in Docker. We say containers. In Kubernetes, we say majority times the keyword called pod. Okay. Inside pod, what will be there? Container.
Container.
How container will get created?
Image.
Image. Okay. Good. Two things very important in the Kubernetes. When I say Kubernetes, one is master, another is the worker. Here, pods will be running. What is that inside? Containers will be running. Why we are using this guy? This guy is the one who will manage where to go the pod, in which worker node. Like if one worker node goes down, bringing up the new pod into another container, this is the guy job. Okay, master. If master goes down, your applications will not impact. They'll be running on where? Worker. This is the guy will manage the worker. Let's say, for example, if master goes down, if one of worker goes down, that pods, bringing up the new pods will get impacted because that information is with whom? With this master guy. Okay. Good. Two things important. In Kubernetes architecture, master will be there, worker will be there. In the worker, your pods will be running. What is worker? It is nothing but EC2 only. It's a group of EC2 workers. EC2s will be there. Tell me, one software will be running in the workers. What you know?
Docker major.
Where are the containers are running in this flow? And the master or workers?
Workers.
Workers. What did I told? What they will be running? What is the keyword I told? What they're running on the worker? Containers.
Pods
right?
are containers.
Yeah. To run the containers, you need one technology.
Docker.
So
Kubernetes.
behind Kubernetes, what technology they are using to run the containers again?
Docker.
Docker. But that linking multiple EC2 missions, everything that they took care. Multiple EC2 missions and all. Yes. Behind Kubernetes, to run containers, the technology obviously again here, what is coming again?
Docker.
Docker is there. But instead of Docker, nowadays they were calling is a Containerd. They renamed the Docker with another name called Containerd. So you will have a confusion, sure. Again, why? But we don't run Docker run and all. We don't run. That running, who will take care? This guy will take care. This guy will take care. In Docker, you need to do the Docker run, port mapping and all. Here, everything he will take care of that. And which host, which worker and all. Very important. We never interact with the workers. We interact only one guy.
Master.
We in the sense as an admin, as a like I want to deploy an image. We don't give it to worker as a. We interact with only one component. In case this is called master. Then master will interact with whom? Workers.
Workers.
As a DevOps guy or the developer, like whatever the team. Just for example, okay, DevOps will say, I will specify to whom. I'll talk to whom? Master. And then master will talk to workers. Here, what will be running? Pods will be running. These workers will get connected to whom? load balancer. The target groups will be there behind. These guys will be the target groups. And then here is the R53 will come. R53. As a DevOps guy, he will be telling, hey, take this image version 2, image version 3, image version 4, whatever. Talk to master. This master will decide on which worker node is free, which worker node is having like something more burden. It will avoid that. It will select this. Master will select on which worker node it has to go. In case if worker node goes down one worker, because you told I need always one image to be running, one pod to be running, this master will schedule in another worker automatically. That's fair. That's where this beauty of the management technology. These two are called Kubernetes. In each case, this guy will be taken care by the cloud provider. Your job is to take care of these guys. If this worker goes down, one node goes down, you have to bring it up. That is what your job. And then the pods will automatically will get scheduled. You don't need to deploy anything. That guy master will take care. Any doubts on these things? Any thoughts you want to ask? Any queries? Behind EKS, what technology they'll be using to run the containers again?
Docker.
Docker only. But we don't run Docker run and all. That they'll take care automatically. That they made a like framework, easy framework for us. Cool. So Kubernetes architecture divided into the two components, master and worker. Okay. As admin, if I want to interact with the Kubernetes, we don't interact with these workers. We don't interact with. We don't interact in the sense there is like some kind of things are there. We don't do at all interact it. The best guys to interact is the master. Thus, master internally will talk to two workers again. Now, I'm telling it. We interact with master, right? Same. We interact with EC2. Interact in the sense login, telling instruction something. Okay. You know already. Please tell me now. This is very important. You know already EC2. I'll compare with that there. Okay. I want to log in inside EC2. What and all I need?
SSH. Okay.
What is the tool we are using? SSH client in our laptop?
Bash.
Git bash.
Yeah, yeah. Next.
Need a PEM file.
PEM file.
PEM file, another name? What is the PEM file, another name?
Private key.
Public key will be there in the where? Both together, right? Private key means your private key is comparing with another key also somewhere. You remember?
In SSH ID_RSA.pub.
.pub. This file we had given to whom? Where did we uploaded this guy?
AWS.
The AWS console. It is there as a what is that? Key pair.
Key pair.
That went into automatically to whom? Internally to EC2.
EC2.
It will be there in the EC2, whatever the user you are connecting it internally. Yeah, next. PEM file.
Yeah, public IP.
Very important. IP address. Now, can I use? I don't want to directly SSH to EC2. Even if this EC2 goes down, I don't want to track with IP address. Suggest me one solution. You know already. I don't want to remember IP address every time. I need one component, even if my
Elastic IP. Domain name.
Okay. Well, yeah, that is the one. Elastic IP address, one solution, one more. We did this lab as also. If you remember, I created one guy, this guy called the NLB. Behind NLB, I used the EC2. Here, port forwarding ID 22. I was using this endpoint, NLB endpoint. For what purpose? SSH purpose. This even if this EC2 goes down also, I can use always what is one more EC2 I will bring. But this endpoint will be static right now. NLB endpoint. This will not change, right? This thing. We did this lab in the initial time, if you remember. So why I used NLB? Why can't ALB? For this SSH purpose, I used NLB. Why not ALB?
NLP is faster than ALP.
Okay.
That
Okay, that is the one. But not this case, no. You know the answers for this already.
If EC2 is down, then we can't connect through LB, but NLB means we can connect to other EC2.
Like even ALB also, if EC2 goes down, you need to bring one more EC2. I'll bring it up. But I don't want to track with IP address. I need a here endpoint will be there. If you do SSH to this endpoint, this internal will forward NLB to EC2. I mean, we did this lab. We did in our session. I brought a target group. I did for NLP purpose.
ALB is for HTTP and HTTPS protocol.
Exactly. SSH, what SSH, another protocol, right? Like HTTP, there is a protocol. Exactly. Yes. That is what we look for the keyword. Protocols. HTTP, HTTPS, SSH is also one protocol. But underlying these for these two ALBs only. For SSH, right? We need this load balancer. What is this load balancer? TCP protocol. TCP protocol will not be supported by whom?
ALB.
Who will support?
NLB.
NLB. That's why I had used this one. Classic also will support. Classic will support HTTP, HTTPS, TCP, but Classic is legacy. They're telling not to use. If you're using TCP, go for NLB. This is what we discussed, guys. Cool. Now, that's a part. If I want to interact, I need a PEM file, private key, that bigger content. Public key will be there with whom? With EC2. Inside EC2 user, public key will be there. In AWS console, it could have copied internally. They will take care of that. Private key is with you, public key with the cloud. Both are matching, then only you are able to log in inside. To connect, you need IP address or endpoint based upon that configuration, what you have in architecture. So these are the basic things you need if I want to connect to EC2. Same way, I'm telling I want to connect to the master. Somewhere server will be running, right? Here. For this, what server will be running in EC2? To do this, one server will be running EC2. If the server goes down, you cannot connect also. In EC2, if you are doing SSH, one server should be listening. One port should be listening, right?
Apache.
On which port number you will connect to SSH?
22.
So Apache, what is the Apache port number?
80.
So, but you are telling that, like, for example, I'm throwing a stone, you give me the something. No, it's altogether different protocols.
SSHD, right?
Exactly. So one server, you are doing SSH, one guy,
SSHD will be.
this is the server. Okay, cool. So this is the client. SSH is the client command and SSHD is the server. I need these basics to tell in the architecture. Cool. To connect to the EC2, SSHD server should be running. This is called server, service, package, software, different keywords we call, okay? Service, daemon, the package, software, different keywords, system, service, blah, blah, different keywords, okay? This is the client. This is the server. You are interacting internally to this server only. Same way, when I say I'm interacting with master, obviously, here what will be there? Some server or servers will be there. Who will maintain this in the EKS?
AWS.
For AWS maintaining servers, what they give us back? For RDS, do you get IP address?
RDS endpoint.
They'll give endpoint.
Same way, here also you'll have endpoint. Okay? You'll have an endpoint because I'm interacting, right? As an admin, I want to interact. If I want to interact mission to mission, what do you need? IP address or endpoint?
Endpoint.
Here, IP address behind endpoint also, what will be there? IP address will be there. Sure. Without IP
Right.
address, nothing will work. Global formula is underlying IP should be there. That is. But who will take care of that IP management and all? AWS will take care for you. You don't need to care that. Because in case the IP goes down, bringing it up, that they will take care. That's why they are giving what? Endpoint. Behind IP address management, they will take care. That is the first thing. Now, to this master, you will have an endpoint. That is exactly like you will have it. Same way, you need a one key is here. Private key. Here also you need a private key. Why? To interact with the master. How do you get that key and all? That I will tell you. There are some commands you have to do. Instead of private key, right? We will say one keyword called kubeconfig. This file you need mandatory. This file, kubeconfig file. I have seen the people. Please, I'm telling you here. My environment will be running. Okay, my environment is existing environment will running. One guy will come with, he worked on the Kubernetes knowledge something. I'll ask him. I'll ask him simple. You know already, please. You know, you are not the new guys now. You come to my project. I will say the first day itself, hey, connect to the AWS cloud. What do you guys do? What do you normally do?
Log into the AWS console.
Where is AWS account?
We'll ask which AWS account and what is their credentials.
I have seen the people, they log into their personal account. You see, right? He came to my project. I asked him, that's all. It's up to the people. I mean, that's all what they got it. So always you should ask the question back to us. Where is how to log into AWS, how to get access AWS account, what tools I need to install. You don't ask that question. You should have that knowledge because you are coming with experience. You install Git Bash, AWS CLI, Postman, the Terraform, the Docker. You should have in your laptop. Don't ask, come to the project. That's where we expect you. So same way, when I ask you to account to AWS account, you should ask it how to get an AWS account. Please give me the access. How many AWS accounts are there? How many? These are all you should ask it. The day by day, you should ask it. You should have a questionnaire, something. What questions you need to ask it, like something. Same way, if one person comes to Kubernetes project, we are running EKS in the cloud. We ask them this question: Can you connect? Can you connect to cluster? The first question you should ask back us. Please ask this question: from where I can access the cluster? You have it? Bastion, or do we access from local? Like, what is the mechanism? You should ask back because that is you should ask back. Okay, this is you should ask. That's how the project. Okay, now, like for example, yes, something I'll say like from the local only. We are going with the local only. Then you should ask very important. How to get the kubeconfig? Do we have any process? Usually people, what they do, all these steps, because they cannot tell you individual people, right? They'll make a documentation, all these steps. You have to follow the documentation. That is called wiki, Confluence wiki. Okay. In this wiki, we will follow. You ask them, do you have a wiki for that setup and all something? So majority company people, they'll maintain because we cannot explain to individually, right? We want to say that in something. So very important to connect to the cluster, you need this file, kubeconfig. Without this kubeconfig, you cannot connect to the cluster. Very important file. What info will be there? So here, what is the thing you are doing here? Individually, you are running, right? This command. What is this? SSH, FNI, PEM, blah, 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 like that user and all, right? All these combining, this is like one kind of kube config. This is I can say it is a one YAML. This is a one YAML. It will be like this kind config endpoint. To whom do you interact in the Kubernetes?
Docker.
In Kubernetes, you have an architecture, master and worker.
Master. Master.
To whom do we talk?
Master.
Master. Where is the Kubernetes running? In EC2 or in EKS?
EKS.
Do we have a IP address or endpoint?
Endpoint.
This is what here. Endpoint URL will be there.
Master endpoint.
There is a one command. If you do that, automatically it will create. You no need to prepare anything. Just I'm telling you that more. Here, some kind of what I can say TLS. Okay, I'll say that PEM file. Something called keys. Here, blah 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 like that. Bigger like encrypted content will be there. Something. Okay. Behind some kind of user, that information will be there. This thing. Colon port number will be there. Some port number master. This. So you need this file. Without this file, you cannot connect to the cluster. Very important file. This file, not for workers. This file is having information of whom to contact. Only to the master. Now, let me go. Where is this file?
In AKS.
Local. Okay. In your home directory, .cube folder. Now you know in the home directory, tell me what are the folders, some important folders. You know already.
.tf. .aws.
AWS, one more.
SSH. .q.
Here, you will have a what? Here, what is the guys?
Private, like IDS underscore ID underscore RSA. Again.
Here, what is the file? Config file will be there. This is a single config file. In this config file, you will have all this. This is YAML only, okay? YAML file only. But instead of .yaml, they'll say config only, okay? You will have all this information now. Now, you remember, I'm running this command, AWS, or let's say I'm doing Terraform, apply. From where the credentials will pick it up?
AWS CLI.
Where is the credentials? I'm running in my local this command. From which folder it will pick the credentials?
Home directory.
From
AWS.
From this folder, right? For Terraform, do you give username, password, or access key, secret key? From outside.
Access key secret.
Access key, secret key. That is there in the home directory, right? Now.
Yeah.
This is for Terraform. Internally, it will interact with AWS. Now, you want to interact with whom? Kubernetes. Only the guy you will talk to whom?
Master.
Master. Behind master will be there, worker. This is your laptop. Okay, laptop. What file do you need? .cube config. In this config, you have master information. Okay. What is the tool did you use to provision infrastructure?
Visual Studio.
What is the tool did you use to provision the infrastructure? Not to write. Terraform. What is the tool? Client tool you are using to run the containers? Docker. Individual containers. What is the tool do you use to log into EC2?
Bash. Git bash.
Bash.
You are not using Git bash internally. You are using one command.
SSH.
No, SSH is the server. You are using a client. I'm telling client, okay? I'm targeting on the client. What is the client tool you use to access Apache? I'm asking the questions here. Clients only, I'm targeting clients.
Browser.
Apache. Browser. Tell me some more tools you know. CLI tools. Tell me some more tools also. I want to access Apache other than the browser. You know already.
Postman. Curl. wget.
All these you can use, right? Curl also I can use, but wget also I can use, right? To test locally, command line. These are the GU tools, okay? Now say, log into EC2. What is the client?
SSH.
One more.
SSM. Docker. Terraform.
Please answer it.
AW-
I'll be very
AWS.
STS get
AWS
caller
con-
identity.
Yeah. So what is the command you are using? What is the client tool you are using here?
AWS.
AWS.
This is called, people used to say, what is that? They used to say AWS CLI.
CLI.
Okay. So all these are client tools. What are the client tools you know? You know? The browser, the Postman, curl, wget, SSH, and then the AWS CLI, Terraform, all these, exactly, Docker, all these are clients. Same way, if you want to interact with the master is the server. Okay. Same way. If I want to interact with master, this is the Kubernetes. You need one client tool in your laptop. kubectl. kubectl is the client to interact with whom? With K-test cluster.
Clusters.
When I say K-test cluster, two things: master or worker. Do we connect to worker or master?
Master.
So kubectl will connect to whom?
Master.
Exactly. We cannot connect to this guy directly. We don't do also. This guy is our important guy as an admin under. But where the application is running?
Workers.
Workers. We don't run. Can I run the application on the masters? In case, no. In your own setup, you can run. If you set up the Kubernetes right, you can do, but not at all. Best place to worker. Okay, cool. So very important. Applications run on the worker. Pods, containers, and all will be running here. We will interact with this guy. What is the tool we need to have in our laptop is the kubectl. If I say how to check how many images are there in the, how many containers are running in the Docker?
Sudo docker ps.
Docker PS.
So Docker ps, right? But in the
Yeah.
Kubernetes, right, we will run this command. kubectl
kubectl.
get pods. Get is for to get the more data, more like get command. Now, one second. You are running this command. Where is this command? Where you have?
We have in our local. Yes, we have installed.
Exactly. So in your laptop, kubectl client. Okay. Now let's say I have installed, let's say you came to my project, I asked him, you followed something you already have in your laptop. kubectl is there. The first question I asked you, connect to the cluster. So you know now to connect to the Kubernetes cluster, what is the tool you need? kubectl. Very good. Next, what is the thing you need? kubectl is not
And master endpoint.
master endpoint, but we don't give individually that master endpoint to anyone. Yes, you need a master endpoint, PEM file, private key, all those we combine into one file. It will be one file only, all that information. What is that file called?
Config file.
Exactly. Combining of all master endpoint, user, some keys, all together it is called, what is the file? Kube config.
Config.
What is the kube config? To authenticate to, what is the PEM file? To authenticate to SSH server.
EC.
What is the
Yes.
AWS credentials? To authenticate to cloud.
Cloud.
Same way, what is the kube config? Kube config is the file. Authentication to whom? Master. Master will check that. When you do simple command, right? kubectl, when you do Terraform, automatically it is going to home directory, right? Automatically it is going to home directory. From here, credentials, it is fetching automatically. You are not telling go to here and all. Same way, when you say kubectl command, this automatically will go to this folder. Automatically. From here, it will take and then will talk to whom? Master. When you're running a kubectl command, which file you are internally passing to master? You are passing this file. This file you are passing to master. Then master will check this config file is correct or not. Whether he has the permissions to access something or not. It will check. Then based upon the command, it will allow to run to do some other operations. Okay, cool. Very important. When I say Kubernetes, you know, managed, unmanaged. Unmanaged is our own EC2. 1 second. Managed, what is the guide?
EKS.
EKS. When I say Kubernetes, two things: master,
Worker.
workers. Workers are nothing but a group of EC2s. What software will be installed on top of that? Docker will be there. In EKS, who will take care of this responsibility?
AWS.
This we take care. We manage this. Now, if you want, this is altogether is called a cluster. If you want to connect to this cluster, very important, from where you are connecting it, what is the file
kubectl.
you need?
Kubeconfig.
Kubeconfig. That we call as a kubeconfig. In your home directory will be there. What is the tool do we use to connect to the
kubectl.
kubectl. Any thoughts you want to ask till now? Any doubts you want to ask? Okay, let me ask you this question. In AWS, which service is checking your credentials correct or not? I'm running this command, okay? I'm running this command, Terraform apply. From where it fetches credentials?
AWS
Not
CLI.
AWS.
From where it fetches credentials? From this is running from my local, okay? I'll tell you very clearly. Local. From where it is fetching credentials?
.aws folder.
It is. What are the files will be there here?
Config file and
config.
credential file.
Credentials file. Yeah, what information will be there inside these files?
Access key, secret key.
Access key, secret key. Okay. Access key, secret key, you generate for whom? You tell me now. You have to tell this.
To connect to AWS console.
No, no, not purpose. To whom you generate this thing?
Users.
I am using.
Awesome. Very important. This is I am users only, not for role. Roles also you can generate. That is some temporary STS and all something you have to do. Role also can generate the credentials, but yes, I am user. Okay. Now I'm doing Terraform apply. I was trying to create S3 bucket. I was not able to do. What is the correction I have to take care? You getting? I'm doing Terraform apply. I have wrote the Terraform code to create S3 bucket. I'm doing Terraform apply. It is saying that you are not allowed to do this operation. What could
Because they don't have like access to that. We have to change the role.
IAM policy.
to whom? Role, user, EC2, or something kind of or Route 53. What is the option? Let me tell you. I wrote the Terraform code. From my local, I'm applying it. I'm getting permission denied error something. Options below. 1. As you said, you have to tell me what to. I don't want to give options also.
Yeah, we have to allow, like we have to give the IAM role to S3.
Okay. From
The-
where
the
on
user-
Terraform apply? IAM role where? From your local, you can access IAM role or within the cloud.
Is in the cloud.
But I'm doing from my local, outside. That's okay. We need this confusion. Then only the clarity.
Yeah,
will-
we have to check the configuration.
To where? Where? The keyword is very good saying that configuration.
In like AWS CLI, we have to go and check. We have allowed or not.
I'm using this access key secret key in my local. So I'm doing from Terraform apply. Access key secret key of this is doesn't have a permissions to access S3. Then only the guy you need to modify here. Update
S3 policy.
for this user only. Okay. No. So very important. Now, when you say from my local I'm running, obviously you know access key secret key. In AWS, which service is checking whether you have the permissions or not? In AWS.
IAM.
IAM, right? Exactly. IAM, before running any commands, when you do any command running in your local, that commands instructions are going to which service first in AWS?
IAM.
IAM. The IAM is the one checking your authentication. Credentials correct or not. First, it is checking authentication. Second, it is checking what? Do you have a policy or not?
Policy access.
Two things it is checking. IAM. One is
Authentication.
authentication is
Policy
correct
access.
access key, secret key or not. That access key is live or not, active or not. Then it is checking what?
Authorization
Can
policy.
you say me one keyword? What is authorization? What will come here? Simple.
Policy and role.
Policies only. Obviously, internally policies only. Same way, master also will do the same. When you give a kube config, right? Same. Please bear with me. Whatever I am, concepts are there. Same concepts are everywhere. This is called RBAC. RBAC, role-based access control. This RBAC is there in our home also. You cannot allow other people to come to in our home. Even if you allow, you have authorization. You cannot allow him to go inside some locker room. You can. That's what, right? RBAC, IAM is there everywhere. Wherever you go, there is a governance is there. You go to anywhere, you cannot behave like odd. So because you have authorization, some restrictions are there. With that, right? IAM concepts are there here also. Just keep that, okay? What is that? We will see. What does that mean? Here one guy will check your credentials or not, kube config is correct or not. Then does he have a permissions to do something that you can do? So IAM is everywhere. In our home, in Kubernetes, in other technology, everywhere it is there, okay? Just keep that. Cool. Now, like in AWS, what what is the service is managing your authentication and authorization? EC2, S3, IAM, Route 53. Which one? In AWS, who is managing your authentication authorization? I'm giving options: EC2, S3, IAM, Route 53.
I am.
I am.
Right? Same, what Kubernetes people did, they break master again into some components. They break again some components. API server, one more called etcd, one more called controllers. We don't care any about these things, please. This is for interview point of view, I'm telling it. In the interview, they'll ask you. Okay? This is the guy equal to IAM. Okay. This is the guy equal to IAM. He will check your config is correct or not. He will check that does he have the permissions or not. One guy called API server in the master. Let me put it to one simple image. Yes. This is the guy. Yes. Open a menu tab. Yes. This is the guy. These two are workers. Okay. These two are workers. These two are workers. Okay. I am the admin guy. I have a kube config of the master. Then whatever commands I'm telling it, every command will go to who? API server. API server will check you are the correct command or not. Do you have the permissions or not? Then it will take a rest. You tell that instructions, this will take a rest. You have to tell the instructions, that's it. Next, it will take care anything here, okay? So let me, one more guy is there, scheduler. Scheduler. So let's pass it here. I'll pass it here. So let's, let me just a minute. Yeah, so make this case. This case interaction. Just a minute. System results. Good. Can you guys tell me here? Reviewing what did you learn today? Please, can you guys anyone talk?
Yeah, we have learned about how to, like, what are the things will be there in the Kubernetes, like how it will work, which is with directly like K8 and with the EKS. What is the drawbacks and pluses the EKS and K8s? And we have learned about master and worker, and how to interact with master and how to interact with the worker.
Do we interact with workers?
No, not directly. Master will interact with workers.
Yeah. Okay, it is. What is the tool do you need to interact with the Kubernetes?
Kubernetes, we have to install kubectl Kubernetes. For if it is directly, it is local, we have to install Kubernetes.
I mean, normally to interact with any Kubernetes,
kubectl.
What do you need? Kubectl. One more.
And that kube config.
These two. Without these two, you cannot connect to any cluster. These two are very important. Okay, kubectl. So if anyone comes to you, if they ask you to, I have seen that these questions you should ask is, if someone asks you to connect to the cluster, the other question you should ask it, from where I need to connect. Do you have any server, specific server? What happens here is in the existing projects, right? We will have this guy called Bastion. From this Bastion, we will interact all these K8s clusters. Okay. If you get access to this Bastion, you can access to these clusters automatically. No, some companies I have seen it, they'll access from local only. In this case, already here kubeconfig will be there. They knows it. They could have configured here, but you have to configure here. You need to follow some kind of steps. You need to ask them. This is what your job. Okay. So kubectl is the client to interact with the cluster. Kubeconfig is the file to authenticate to that cluster, and then it will have a permissions. What policies, permissions, RBAC will be there. RBAC is everywhere, right? Okay. Why we are using Kubernetes?
To run a Docker image.
To run
the containers.
What is there inside containers?
Docker images. Application.
So you know two things now. Let me put it here. One, two, Kubernetes. We did this setup, right? WordPress, Apache, Tomcat, Nginx, and all. We did this. Same setup. I'm going to replicate here. Same setup. The I told na WordPress. Once we familiarize WordPress, I'll bring my own application where the n number of components will interact it. So you got the objective, right? We will be setting up that the Apache, Nginx, Tomcat, Grafana, Kibana, all that on top of this guy. Okay. That is what next our objective. So for this, I'll be using EKS. Good. So let's pass it here. We'll continue tomorrow. Thank you, guys. Guys, please download the videos. Please, that some accounts issues are there. Please download as immediately. Request you guys. Thank you.
Thank you.